Hello, my fellow critters and creatures. When was the last time you played hide and seek? We're going to be looking at several animals that are amazing at this game and diving into the mechanisms behind it. Let's get into it. The first technique we're going to be looking at is concealing coloration. This is when an animal matches the background behind it, like with many varieties of wildcats, where they look like the shadows that are cast on the leaves above them, or snowy owls that, as the name suggests, look like the snow. Another technique is disruptive coloration, where it breaks up the outlines of the animal and makes it hard to see what is animal and what is not. Like zebras, when they're bunched up in a huge herd, it makes it so all the outlines of the zebra sort of meld together. They all look like one blob. Same thing with fish and coral reefs. Their stripes match the reefs behind them, so it makes it hard to tell what part of them is actually animal and what part is the reef behind them. Another technique is countershading. This is mostly used in ocean life. This is when the top of the animal is darker, so that when a predator looks down on it from above, it looks like the deep ocean below them. But underneath, their belly looks lighter, so when predators are looking up from underneath, it looks like the sky. Another one is mimicry, where animals look like an element of their environment. A lot of mantises do this, like the orchid mantis, which of course looks like an orchid, and the devil's flower mantis, and the spiny flower mantis. There's also one of my favorite geckos, the satanic leaf-tailed gecko. And the chicks of golden plovers also do this. They look like adorable balls of moss. There's also another variation of mimicry, where they look like a different animal, but this isn't usually for blending in. Animals like milk snakes and villicroid butterflies will look like other animals that are more dangerous. Milk snakes look a lot like coral snakes, which are highly venomous, and villicroid butterflies look like monarch butterflies, which are very poisonous. There's also this little guy. You can see what looks like a spider running back and forth, but actually, if you look behind it, you realize that this is the tail of an Iranian spider-tailed viper. Most of its body uses concealing coloration to make it look like the rocks behind it, so only its tail sticks out and looks like a spider, so that birds will come down and try and find a bite to eat, but instead get caught by the viper. Now we're going to start getting into some animals that change their coloration. First, seasonal color shifting. Animals like foxes do this, where in the winter they'll look white, like the snow around them, but then in the spring and fall they'll look brown and look more like the dirt they live in. This is caused by hormones in the fox's body responding to the amount of sunlight in the day. When the days are longer and you get more sunlight, there's more of this hormone, which causes more melanin to appear. But when there's shorter winter months, the shorter days cause melanin receptors to produce less of it. And now for quick changes. There are two major ways that animals will quickly go from one color to another. There are the chromatophores of cephalopods, such as octopods, cuttlefish, squids, etc., and the guanine nanocrystals of chameleons. Let's first look at chromatophores. Chromatophores are a type of cell that has a bunch of natural pigments in it. The cephalopods can expand and contract these chromatophores to cause their rapid color changing across the body. There are many types of these cells based on the color they want to show. There are black and brown ones called melanophores. There are yellow ones that are xanthophores, red ones that are erythophores, and there are also iridophores for that iridescent look. Now, guanine nanocrystals. Have you ever looked at a crystal and moved it around in the sunlight? You can see how the colors sort of shift as you move it around. This is how chameleons change their color. It's called structural color. As the crystal moves, it reflects different light to your eyes that causes the colors to look different. But these guanine crystals make it so they can rapidly change their colors back to their camouflage coat when needed. Thank you for exploring this topic with me. If you want to see more content like this, like and subscribe. Bye!